You're welcome. Today let's solve questions on redox reaction, Jamb questions on redox reactions. So we are going to look at a couple of questions and we will see how to approach questions that has to do with redox reaction. So welcome to class. So when we talk about redox reaction, I've done a video earlier on the introduction to redox reaction where I discussed all the parameters that you can use to define redox reaction. The link is in the comment section or the description section. You will see the link to that video. If you've not seen it, go and watch the video. But when you talk about redox reaction, is a combination of two words, which is reduction and oxidation. Reduction and oxidation. So two things are occurring simultaneously. So a reaction in which oxidation and reduction are occurring at the same time is referred to as a redox reaction. So we're going to see questions now and we'll see how to answer the questions. Here is the first question. In the reaction below, the oxidation number of the reducing agent changes from options. Option A, 0 to +4, 0 to +2, +1 to +2, +1 to +3. How do we approach this question? In order to answer this question, you need to know what a reducing agent is, what an oxidizing agent is. Now, if you look at a redox reaction, for every reaction there are two sides. You have the reactant side, you have the product side. So the reactant side is the side where you have two reactants that are reacting together, and then you have the product side where you have two or more products. So this is the equation. Zinc is reacting with copper 2 sulfate to give you zinc sulfate and copper as solid. And the question says in the reaction below, the oxidation number of the reducing agent changes from what? So you need to understand which of these is the reducing agent, which is the oxidizing agent. Now, one of the first things you need to understand is that for a reaction, you have two sides. Can you see this arrow is dividing this reaction into the reactant side? So everything on this left side is the reactant and this is the product. The first thing to note is that whenever you are asked the oxidizing agent and the reducing agent, the answer can only be on the reactant side. Okay, so what that means is that the oxidizing agent is going to be either of these two, and then the reducing agent is going to be either of these two. The answer to that question can never be on the product side, because these are products of what had occurred in the reactant side. So this is where the oxidizing agent and the reducing agent will react together. Is that okay? That is number one. Number two, when you are asked the question, which of the following species has been oxidized or which has been reduced, take note, the answer cannot be on the product side. The answer will be on the reactant side. Why and how do I mean? The oxidizing agent is the one that will be reduced. Let me take that again. The oxidizing agent will be reduced, and the reducing agent will be oxidized. So if the question is asking you which of the species has been oxidized, they are simply asking you what is the reducing agent, because the reducing agent is the one that will be oxidized. And when the question says which of the species has been reduced, they are simply asking you which of them is the oxidizing agent. Are we together? So it is the oxidizing agent that will be reduced and the reducing agent that will be oxidized. So I've given you 2 points already. Number one, I told you your oxidizing agent, your reducing agent will always be on the reactant side. And then I told you that the oxidizing agent is the one that will be reduced. The reducing agent is the one that will be oxidized. Okay, so this is a key you need to take note of. So let me give you this illustration. There was some time ago in this country, Nigeria, one of the politicians came on board and he said he is a change agent. And then when he came into office as the president, he actually changed things, right? But he himself was not changed. He remained unchanged, okay? He remained the same person, but he changed things, all right? So that means a change agent changes things, but he himself is not changed. So that means an oxidizing agent will oxidize the other person or the other species, but itself will not be oxidized. Are you getting it? So the oxidizing agent will oxidize the other species, while itself will be reduced, and then the reducing agent will reduce the other species, but itself will be oxidized. I believe that illustration is clear. Now let's try to answer the question on the board. In the reaction below, the oxidation number of the reducing agent changes from. So the question is, which of these is the reducing agent? Now, there are about 6 parameters which I discussed in my video on introduction to redox reaction. I discussed 6 parameters that you can use to define oxidation and reduction. I defined number 1 in terms of oxygen, which is the popular one that most of you students are aware of. But redox reaction is much more than oxygen and hydrogen. Now, in terms of oxygen, all right, redox reaction, so in terms of oxygen, oxidation is addition of oxygen, and the reduction is removal of oxygen. That is in terms of oxygen. When you add oxygen to a substance, for example, if I have carbon plus oxygen to give me CO2, so here oxidation has occurred because I've added oxygen to carbon to give me carbon dioxide. And reduction, if I remove oxygen from carbon dioxide to give me carbon plus oxygen, if I reverse this reaction, all right, this is reduction. So carbon dioxide has been reduced to carbon because oxygen has been removed. So this is reduction. That is in terms of oxygen. In terms of hydrogen, reverse is the case. Addition of hydrogen is called reduction, while removal of hydrogen is called oxidation. Let's put that on the board. So I said in terms of hydrogen, oxidation is removal of hydrogen, and reduction is addition of hydrogen. So it's the reverse of what you have for oxygen. For oxygen, addition of oxygen is oxidation, but for hydrogen, in terms of hydrogen, reduction is addition of hydrogen. So here, if I have C2H4, or let me use C2H6, it will undergo reduction if I remove, so we said oxidation is removal of hydrogen. So if I remove hydrogen from here, I have C2H4 plus hydrogen gas. So this is ethane, this is ethene. Okay, so this reaction by which hydrogen has been removed is what you call oxidation. So oxidation has occurred here, while reduction, reverse of it, if I have my ethane, if I add hydrogen to it, I have C2H6. So this is what you call reduction. So that means an alkene undergoes reduction to give you an alkane. This is ethane, undergoes reduction to give you ethane. I hope that is clear. So that is in terms of oxygen and in terms of hydrogen. Now, as we answer questions, we will discuss the other parameters for defining redox reaction. But then, if you have not checked my video, remember to go check the video so that you can see a comprehensive explanation on redox reaction. So to answer this question, in the reaction below, the oxidation number of the reducing agent. So what's the reducing agent? This chain, this is called, can you see zinc was standing alone here, but by the time it got to this side, sulfate had been added to zinc, so you have zinc sulfate. So oxygen had been added to zinc, that That means this chain is oxidation chain. And then here, copper 2 sulfate add oxygen, but at the product side, it had lost oxygen, now becoming copper alone. So that means this is our reduction chain. Reduction had happened here, oxidation had happened here. Now, another point to note is this: you cannot find an oxidizing agent in an oxidation chain. You can only find a reducing agent in an oxidation chain. So when you have a question like this, the best thing to do is just draw a chain. All right, this is the oxidation chain because zinc had gotten oxygen and you have zinc sulfate. So this is oxidation chain, and because you cannot have an oxidizing agent in an oxidation chain, what you have here will be, this will be your reducing agent. All right, so zinc is your reducing agent while this is your oxidizing agent. So if the question is saying in the reaction, the oxidation number of the reducing agent changes from what to what? Oxidation number of zinc here is 0. Because anytime a neutral atom of an element is in a reaction, the oxidation number is 0. So here there is no plus or minus, it's a neutral atom. Oxidation here is 0. But by the time it got here, this is zinc 2 sulfate. How do I know? If you ionize zinc sulfate like this, you are going to have zinc 2 plus and SO4 2 minus. So both of them are having oxidation number of 2. But the 2 had cancelled out each other to give 1 1. Okay, that was how we got zinc 1 SO4 1, zinc sulfate that you have here. But originally the oxidation number of zinc is 2. Alright, here, that is why the correct answer will be 0 to plus 2. 0 to plus 2, and this is the correct answer. Alright? 0 to plus 2. Now, in case you are confused here, I have also done a video on how to calculate the oxidation number of elements in a compound. Do well to check the video. I have dropped the link in the description section of this video. Alright? So, assuming you had an element that has oxidation of 1, for example, let us take sodium. Sodium has oxidation number of plus 1, reacting with sulfate, which is minus 2, 1 and minus 2. So they will exchange their oxidation number, and that will be Na2SO4. So in this situation, the oxidation number of sodium is 1. Sulfate is the owner of these 2. But for this case, the 2 of zinc have been cancelled by the 2 of the sulfate. And that is why you have this. Can you see 2 is not here? So that means the oxidation number of zinc is 2. And that means the oxidation number changed from 0 to plus 2. This is the answer to the question. Let's look at another example. Before I proceed, if you have not subscribed to our channel, do well to hit the subscribe button right now and subscribe to our channel. And if you have subscribed, please do well to hit the notification bell so that you can see, you can get notified when we post a new content. Now, here is the second question. H2O, water, is reacting with carbon, which is the solid carbon, all right, to give you hydrogen gas and carbon 2 oxide, CO. Then the question says the oxidizing agent in the reaction is dash. Remember, I told you your answer will never be on the product side. So that means by elimination method, this cannot be the answer. H2 and CO cannot be the answer. So the answer is either B or C. And here, this carbon is not having oxygen. Water is having oxygen. So this is the oxidizing agent. And this is the reducing agent. How do I know? This reducing agent, by the time carbon gets to this side, it becomes oxidized. It's now carrying oxygen. So this water had oxidized the carbon. And therefore, water had been reduced to H2. And you remember, the oxidizing agent will be reduced. The reducing agent will be oxidized. So the question says the oxidizing agent in the reaction is, the answer is H2O. So our answer is C. That is the oxidizing agent. Let us look at more questions. Now here is the Next question, in the reaction, 2 moles of hydrogen, 2 moles of water, H2O, reacting with fluorine gas. Alright? And then you have hydrogen fluoride, and you have oxygen as the product, oxygen gas. Now the question says, in the reaction, the substance that is being reduced is dash. So how do you know the substance that is being reduced? Like I've told you, the answer can neither be either of the two products. So none of this is the answer. So by elimination method, HF, this cannot be the answer, and oxygen gas cannot be the answer. So the answer is either of these two. In the reaction, which of them is being reduced? So what you want to do, draw a chain from here. Can you see it from here to here? Now at this point, fluorine was standing alone without hydrogen, but at this point hydrogen had been added to fluorine, and you remember we said addition of hydrogen is called reduction. So this is a reduction reaction. And I also told you that in a reduction reaction you cannot find a reducing agent, therefore this is the oxidizing agent. Alright, and this reaction, if you draw this chain towards this side, water had oxygen, hydrogen was having oxygen here, but by the time it got here, hydrogen had been removed. Removal of hydrogen is what you call oxidation. So this is our oxidation chain. This oxidation chain. So for that reason, you cannot find an oxidizing agent in an oxidation chain. What you find here is a reducing agent. Therefore, this is our reducing agent. So these are reducing agent, this is our oxidizing agent. So the question says, in the reaction, the substance that is being reduced, I told you the reducing agent cannot be reduced. So it is the oxidizing agent that will be reduced. So the answer, what they are simply asking you is that, what is the oxidizing agent? So the oxidizing agent is fluorine gas. And the oxidizing agent has been reduced to hydrogen fluoride. So our answer is fluorine gas, option C. I hope that is very... Now welcome back. These are 2 questions on the board. I'm going to give you time. You can pause this video, quickly attempt this question, and let's try to solve together. Before I proceed, if you have not subscribed to our channel, do well to hit the subscribe button right now and subscribe to our channel. And if you have subscribed, please do well to hit the notification bell so that you can see, you can get notified when we post a new content. Welcome back. I believe you have answered the question. So let's see together. Number 1. Sodium oxide with water to give you sodium hydroxide and oxygen gas. The substance that is oxidized is dash. So if all you understand under redox is addition of oxygen, you will be confused with this question, because here you have oxygen and you have oxygen here. So that tells you that here the question may not actually be about oxygen. So, but this question says which the substance that is oxidized is what? So let's draw a chain. Can you see from here, this is sodium oxide to sodium hydroxide. Here there was no hydrogen, but here hydrogen had been added, and we said addition of hydrogen is called what? Reduction. So this is a reduction chain, and from here to here, hydrogen had been removed from water to give you ordinary oxygen. So this is oxidation chain. Why? Because oxidation is the removal of hydrogen. Reduction is addition of hydrogen. And I told you that in a reduction chain, you can find an oxidizing agent, not a reducing agent. So this is our oxidizing agent. This is our reducing agent. Right? So the question says the substance that is oxidized. One more time, oxidizing agents cannot be oxidized. So oxidizing agent will be reduced, reducing agent will be oxidized. So when they say the substance that is oxidized, they are simply saying what is the reducing agent. So the answer is water. So H2O is the reducing agent. And the last question here, this has to do with balancing of redox reaction. I've also done a video on that. You need to check the description to see the link to that video. Now, what you're meant to do here, you have to first inspect the equation, balance the elements, ensure that all the elements on the reactant side and the product side are balanced, and then you inspect for the number of charges. The total number of charge on this side must be the total number of charge on this side. So any side that has higher amount of charge, you try to add to the lower side to make it balanced. So here, manganese is 1,1, iron is 5,5, oxygen is 4, oxygen is 4, hydrogen is 8. So from that, we can actually guess that our Y is going to be hydrogen, 8 hydrogen. But before we conclude that is hydrogen, let us inspect the charges. So what is the total number of charges on this side? This is 2 times 5, this is 10 plus 10, and this is 8 times plus 1, that is plus 8. So 8 plus 10, that is 18. 18, this is minus 1. 18 minus 1, the total number of charge on this side is plus 17. And then let's check for this side. 3 times 5 is 15, plus 2, that is plus 17. So you have plus 17 plus 17. Therefore, the correct answer is 8 hydrogen here. Now I'm going to drop a final question for you. I want you to solve it. Go to the comment section and drop your answers there, and I will be back to check. Here is the question. So here's the question. You have silver nitrate, silver triazonitrate 5, reacting with pH 3, reacting with water to give you silver H3PO3, then 6H2HNO3 triazonitrate 5 acid. And you were asked to find in the reaction the reducing agent is dash. So which of these is the reducing agent? I want to believe you will be able to attempt this question. So go to the comment section and drop your answers there. Thank you for being a part of today's class. My name is Coach Paul, and on this channel we give you contents on physics, on chemistry, on biology, on mathematics to prepare you for your Jamb exams and every other exam that you have. I want you to subscribe to this channel if you have not done so, and remember to hit the notification bell, and do well to share this video with your friends and your colleagues. Thank you for being a part of today's class. See you in the next class. Bye for now.